We are starting our first lecture. It is organic chemistry of the course code is 9701 AS level organic chemistry. So the first topic is alkane, alkane. Actually alkanes are, they are saturated hydrocarbons. Alkanes are the class of they are saturated hydrocarbons. So mostly he asks question for 1 mark, what are hydrocarbons? So you will answer those compounds containing carbon and hydrogen only, okay? So what is saturated? Saturated mean if there is carbon to carbon single bond is present. If carbon to carbon single bond is present, so it is known as saturated hydrocarbons. Because alkanes only contains carbon to carbon single bond, they cannot add any other thing because they are less reactive. Alkanes are less reactive. So why alkanes are less reactive? What could be the reason behind this? If you notice, like carbon to carbon bond, carbon to carbon, and carbon to this hydrogen, okay? If you check the electronegativity difference of these two, it is a very less. For example, carbon has electronegativity of 2.5 and hydrogen has electronegativity of 2.1. If you check their difference, you will get 0.4. So if electronegativity difference is very low, it means there is no polarity. So it means they are non-polar compounds. They are non-polar. Like there's no negative charge, there's no positive charge. They are not a polar compound. It is the reason, okay? So they are non-polar, they are less reactive, so they have bond energy is higher. Bond energy is high. So it means it is difficult to break their bonds among carbon to carbon or carbon to hydrogen. So this is the reason saturated hydrocarbons are alkanes and they are less reactive in nature. They're difficult to react. Okay. So the next thing is if we like proceed the next page, how to get the next page? I don't know. From where I will get the next page. Okay. So the next page is okay, their general properties. They have like intermolecular forces, temporary dipoles. They have temporary dipole forces. Okay. So it means their intermolecular forces are weak. Okay. They have weak intermolecular forces. Okay. They have weak intermolecular forces because there's no any electronegative atom connected with them. It is the reason they have temporary dipole forces. Okay. And as I already told you, they are not polar. If they are non-polar, okay, so it means they are not soluble in water. They are insoluble in water. Okay. They are insoluble in water, but they are soluble in organic compounds. They are easily soluble in organic compounds. Okay, so organic dissolves in organic easily. So if we increase their chain, for example, if we have like one carbon, so it is a simplest alkane. If there's a one carbon, okay, it's a methane. It's a methane. So alkanes, their name ends with ane. The word methamine is a one carbon. It's a one carbon and ane representing carbon to carbon single bonding. Okay. If we have two carbons, for example, carbon to carbon, there are two carbons and there are six hydrogens as well because each carbon can make four bonds. If you check the structure of a carbon, carbon's atomic number is 6, its mass is 12. Okay. So atomic number is a part of group 4 member. It is from group 4 member. Okay. So it means 2 electrons in the first shell and it can have maximum 4 electrons in the outermost shell. So it is the reason carbon can make maximum of 4 bonds, 4 covalent bonds. Okay. So now if there are two carbons, we will use the word eth. Eth mean two carbons, and A and E representing carbon to carbon is three bond. So just like if you have three carbons, one, two, and three, okay, I'm not like writing hydrogens now. There are three carbons, so we name it prop. Prop mean when there are three carbons. So ends with A and E. A and E mean there are carbon to carbon single bond and it is some alkane. Okay. So you people have to memorize this. For example, you have to memorize if one carbon is there, methane, meth. If two carbons are there, then eth, ETH. If there are three carbons, you will name it like prop, propane. Okay. For four carbons, you will use the butane, it will become butane. If there are five carbons, you will name it pent, it will become pentane. Just add ane because if there's a carbon to carbon single bond, you will write ane. Pentane, hexane, propane, butane, okay, and pentane. Understand? If the six carbons, you will name it like hex, hexamin 6, hexane, this is some alkane, okay. 7 carbon, hept, so it will become heptane, understand. And if you have there like 8 carbons, so you will do oct, it will become octane. If you have 9 carbons, it will become nonane. If you have 10 carbons, it will become deca, so decane. Is it clear? So you have to memorize for one carbon, two carbon, three carbons, meth at probute pent. So the last name, stem name, its name is actually known as stem name, represents nature of your functional group. What type of functional group is there? What type of bonding is there? Okay. So as the carbon chain increases, for example, if there's a one carbon like methane, some methane, so one carbon, okay. You have ethane if there are two carbons. So their melting and boiling points also increase. You can say when carbon numbers are increasing, hydrogens also increasing. You are noticing here. Is it clear? So it's a propane and the next one is the butane. You can call it, there are four carbons, so they are known as butane. Okay. So you can see if we increase the carbon chain is increases. Okay, carbon chain, carbon increase. It means their melting points and boiling points, they also increase. Okay, melting point and boiling point also increase. Why? Because number of atoms are increasing, number of electrons are increasing. Okay, number of atoms, number of atoms, or you can say number of electrons, okay, they are increasing. Understand? Is it clear? So when increase the carbon, their molar mass is also increases, molecular mass. Okay, so their molecular mass also increasing, mass increase. Understand? So when we increase carbon length, carbon chain is increasing. You can notice their carbon melting and boiling point increase. Number of atoms also increasing. Their molecular mass is increasing. Okay, so their physical properties are being changed. Their physical properties are being changed by increasing their carbon length. Okay, so if we further look into this, so their general formula is for alkanes. If you are having alkane, and if we talk about their general formula, if we talk about their general formula, is it? It is CnH2n plus 2. So what is small n here? Actually, this n is number of carbons. It is representing number of carbons. Okay. And n is equal to minimum, it is equal to 1, then 2, then 3, and so on. Okay. For example, if you have pentane. You want to draw the structure of this pentane. Pent mean I already told you there are 5 carbons. So it means N is equal to 5 because carbons are 5, N is equal to 5. So I will write it here C instead of N, I will write it here 5. H2, 2, and instead of N I will write here 5 plus 2. It will become C5, 5 multiplied with 2, 10, 10 plus 2, 12. It will become 12, C5H12. So let me solve another example, give you another example. If you heptane, heptane means 7 carbons are there. Suppose if you have 7 carbons, 7 carbon, okay. So your N will be equal to 7. So you will use the formula C7H2. Instead of N, I will put it here 7 plus 2. So when I will solve it, it will become C7. 7 twos are 14 plus 2, 16. H16 is the formula of heptane, okay, when there are 7 carbons. So these were little bit physical properties, and it was a little bit general idea about alkanes. Now we will like talk about their chemical properties, okay. Chemical properties depends upon their electrons and chemical reactions, okay. Chemical properties, you know, chemically they can give 3 type of the reactions. So if we look into this, the first one, is a combustion reaction, okay. There are 3 type of reactions. First one is a combustion reaction. What is combustion reaction? Burning of substance in the presence of oxygen. What's the combustion reaction? It is actually burning of a substance, burning of substance in the presence of oxygen, okay. If something is burning in the presence of oxygen, we call it a combustion reaction, okay. Suppose you have a CH4 methane gas, an ordinary gas at our home, okay, so it is burning in the presence of oxygen. So when a hydrocarbon burn, you have to memorize, you will get 2 products, carbon dioxide and water. Whenever a hydrocarbon burn, your products are like always carbon dioxide and water, okay. Just you have to need to balance the equation. There's the 1 carbon, here's a 1 carbon, okay. There are 4 hydrogens, but there are 2, so I will put it here 2. 2 twos are 4. So 2 multiply with this oxygen as well. 2 oxygen, 2, 4 oxygens are there. I will put it here 2. It is a journal, like it's a combustion equation, okay. If there is like supply of oxygen is like plenty supply of oxygen. If oxygen is like in excess, or you can say oxygen is in excess, okay, it is known as complete combustion. It is known as complete combustion. Complete combustion is when you are burning something in the presence of excess of, okay, excess of oxygen, okay. If supply of oxygen is excess, it is known as complete combustion, and you will get this carbon dioxide, okay. But if you have a limited supply of oxygen, for example, if you have CH4 and oxygen supply is limited, then you will get carbon monoxide, a toxic gas, okay. Carbon monoxide is a toxic gas, and then you will get water. So it is actually the type of incomplete combustion. When you get carbon monoxide, it is actually a incomplete combustion, okay. Incomplete combustion, okay. And you get carbon monoxide in this case. And carbon monoxide, it combines with hemoglobin, okay. It combines with our hemoglobin, and it produces oxyhemoglobin, okay, and cause suffocation, and cause suffocation, okay. So the person can die and death happen, okay. So the major problem for carbon monoxide is, if we talk about carbon monoxide, It is like colorless. It is a colorless gas and it is odorless. Okay, so we cannot like feel its presence in the room, and it is highly a toxic gas. If someone talk about carbon monoxide, you can easily talk about it is highly toxic gas. Okay, so combustion, two type of combustion: complete combustion when the supply is like excess oxygen. If supply of oxygen is limited, it means it is incomplete combustion. Okay, if supply of oxygen is limited, so one of your product would be carbon monoxide. Understand? So next we have like journal combustion equation. Journal combustion equation. Okay, journal combustion equation. Understand? So how can we write, for example, you have any hydrocarbon, C, X is the number of carbons, Hy, Y representing number of like atoms of the hydrogen. Okay, so plus you will add it X plus Y over 4. Okay, X plus Y over 4 closed. And of course, if it is burning in the presence of oxygen, O2, and now you will put it here, X CO2 plus you will write it here y by 2 water. Okay, so X is like you can see it's the number of carbon atoms. So if for example you have C3H8, okay, if you have C3H8, so you can easily instead of X you will put, instead of X you will put 3 plus 8 over 4. Understand? O2, and you will get like if carbon is C3, so you will get X mean 3 CO2, and Y is equal to like H is equal to Y 8, so you will get 8 over 2 H2O. Okay, so by putting this value you can easily like balance the hydrocarbon combustion equation. So you will get C3H8. If you solve this value it will become 5O2. Understand? And you will get this 3 moles of carbon dioxide plus you will get 4H2O. It is your final equation. So you people can memorize this journal combustion equation, and which is also helpful for balancing your combustion equations. Understand? Okay, so what is the problem of this combustion? It is creating carbon dioxide and it can like cause global warming. Okay, it can cause greenhouse effect, which is like further which proceed in like global warming. Okay, it cause global warming, so it means combustion is not a good process, okay, for our environment. Understand? So now next we are studying, okay, so next type of reactions are they are cracking. Okay, number two, first we studied about combustion, second is cracking. Actually, what is cracking? Crack mean it is like conversion of large chain of hydrocarbon into smaller ones. Okay, like your breakdown of is actually breakdown of large hydrocarbons hydrocarbons into like small chains, you can say. Okay, why? The reason is why you are cracking, why you are breaking a large molecule. Large hydrocarbons, like if a long chain, you can say large hydrocarbons. What's the problem with large hydrocarbons? If carbons number are greater, they are less flammable. Okay, like combustible. They are less flammable, difficult to burn. Okay, they are like poor fuel. You cannot use them as a good fuel. They are used as a like poor fuel. Okay, you can say bad fuel as well, because their combustion is not easy. Okay, as a bad fuel you can use it. Okay, other they are more viscous. The large carbon chains are, they are actually more viscous. Okay, so it is the reason petrol and other like fossil fuel we use for our car engines, and for natural gases we use small hydrocarbon chains. Okay, they are like more viscous, they have more density, more masses. So the thing is, when you convert a large change into small change, for example, okay, so you can easily convert them into like C20H72. Okay, so you can convert them into C8H18 plus 6 C2H14. Okay, 24. Okay, 4. Okay, so you can convert them into small fractions. Small fractions means small fractions mean they are like flammable, highly flammable, easy to burn. Okay, they are highly flammable. Okay, they are good fuel as a fuel. Okay, good as a fuel, understand? Okay, low melting and boiling points, low melting points and boiling points, understand? So it is the reason we convert long chain hydrocarbons into their simple ones. Okay, because they have low melting and boiling point. If carbon chain is from carbon number 1 to carbon number 5, so you can say they are gases. Okay, from carbon number 5 to carbon number next 17, you can say they are liquids. Okay, from carbon number 1 to carbon number 5, they are mostly gases. From carbon number 5 to carbon number 17, they are mostly liquids. And from carbon 17 to onwards, they become waxy solids. Okay, alkanes become waxy solids. So now you can take idea okay, when carbon chain is increasing actually, so their properties, their physical properties are totally changed. Okay, and when their physical properties change, then it will become difficult for us to like utilize them. Okay, so we were studying cracking, so we can use cracking in three different ways. So there are three types of cracking. Okay, so here is TCS, you can memorize it. TCS, like thermal, by providing high temperature, thermal cracking, number one. Other, you can use some catalyst, catalytic cracking, and the last one you can say steam cracking. Okay, you can use some steam and to convert that long chain into small hydrocarbon chain. Okay, so this is little bit about their cracking, and in your book you can see the catalytic cracking is like mostly we use some catalyst. Okay, for example Al2O3, Al2O3, you understand? Or we can use silicon dioxide as a catalyst for converting large chains into their small chains. Okay, so the next is the last very important, their chemical reaction, substitution reaction. Okay, alkanes they prefer substitution reactions. They prefer substitution reactions. So how to define substitution reactions? Those reactions in which hydrogen is replaced with some other atom or molecule. Reactions, reactions in which hydrogen, in which a hydrogen is replaced. Okay, substitute. It is actually replaced with other atom or a molecule. These type of reactions are known as substitution reactions. So in alkanes, for example, you have this CH4 methane. Okay, it is CH4. So you are having this chlorine Cl2 molecule. So you are actually substituting this hydrogen with this chlorine. It will become H, like hydrogen, then hydrogen and chlorine. And the other thing will become, it will become HCl, hydrogen and chloride. It will become HCl. Okay. So in this reaction, you can see you are substituting this hydrogen with this chlorine. Okay. Just like this, you can replace one by one all these hydrogens. Okay. So you will get this like CH3Cl, then you can get CH2Cl2, then you can get CHCl3, and then you can get CCl4. Okay, you can see it here. All the four like hydrogens of this, they converted into chlorine. They substituted with this carbon tetrachloride. Okay, so this they will become carbon tetrachloride. So what is the importance of this reaction? The advantage of or importance of this reaction is we are getting different products. Product number 1, product number 2, product number 3, product number 4, product number 5. So advantage is we will get variety of products from a same reaction. Understand? So, but what is the disadvantage? Is there any disadvantage? So disadvantage is their separation. Okay. So the disadvantage is, what's the disadvantage of this reaction? So this disadvantage is separation of products. Okay. Their separation is difficult. Separation is challenging or difficult, you can say. Okay. Costly, time consuming. So it is the disadvantage of this reaction. So the most important question came in your come in your paper. They are the mechanism. So actually alkane they follow free radical mechanism. Free radical reaction mechanism. Okay, reaction mechanism. Understand? What is a free radical? Free radical mean is a species, atom or something species carry unpaired electron. Okay, unpaired electron. If something carry unpaired electron, it is known as free radical. Okay, number one, species which carry unpaired electron. Number two, they are highly reactive. They are actually highly reactive. Okay, if they are highly reactive, it means they are least stable. They are not stable. They are least stable. Okay, radicals are produced with the help of homolytic fission. They are produced with homolytic fission. Okay, so what is homolytic fission? For example, you have chlorine molecule Cl2. For example, you have this Cl2 molecule. Okay, the Cl2 Cl covalent bond with another Cl. Okay, so it is the you can say chlorine is from group 7. So it can have 7 electrons in their valence shell. So it is 1, 2, 3, 4, 5, 6, and it is 7. Okay, another atom 1 electron, 2, 3, 4, 5, 6, and 7 are there. Okay, so when you use any sunlight, any UV radiation, okay, for example, you have UV ultraviolet radiations, they actually break this molecule. Okay, so this electron of it will move towards here, and this electron will move towards this. So you will get this now chlorine, and now let me represent their number of carbon electrons: 1, 2, 3, 4, 5, 6, and 7. Plus, you will get another one is a chlorine. So write the electrons now: 1, 2, 3, 4, 5, 6, and 7. So now you can notice this is an electron pair. This is another electron pair. This is the third electron pair. But one of the electron is unpaired. So the definition in which unpaired electron is available, they are known as the radical. So it is a radical and it is a highly reactive species. So it is electron pair, another electron pair, third electron pair. But you can see this is unpaired electron, okay? So how to represent a radical? So for the representation, you can simply no need to mention this like this. Okay, we just simply, for example, let me write in their proper way how to represent. You will just write this chlorine, this Cl with dot. This dot is representing actually unpaired electron. You will write it here chlorine and you will write it here dot. It is representing this atom has unpaired electron and it is a radical. And what is the condition for creating a radical? There's the UV radiation. Okay, so you can substitute chlorine or bromine in alkanes by using this. So let me explain their mechanism. So free radical reaction has three steps. There are like free radical reaction. It has three steps. Okay, it has three steps. So step number one, it is known as initiation step. You are initiating a free radical. It is a like production of a radical. How a radical is produced. For example, you have that Cl2 molecule. You are using that UV radiation we discussed in the previous slide. You will get two Cl radicals. Okay. So initiate mean you are generating a free radical. Okay. So once a free radical is generated, now it will start reacting because it is a highly reactive. Okay. So the next step is actually propagation step. Step is propagation step. Start propagation. Why it's propagating? I already told you radicals are highly reactive species. Okay. For example, you have CH4, you have this methane. Okay. And you can say here we have this electron of this hydrogen and it is the electron of this carbon. Okay. And next you are reacting this with a radical. So it is a radical with unpaired electron. Okay. So what will happen actually? This radical electron combine with this electron of this hydrogen. Understand? It will become HCl. They will combine together and it will become HCl. And remaining you will get this H carbon with this hydrogen with this electron. Okay, with this carbon electron. So now you can see now this carbon with yellow has unpaired electron. So it means now this carbon become a radical. And what about the other one? This H and Cl, they will combine together. It will become HCl. Is it clear? So in the next step, what will happen in the next step? You can see this H, this carbon with this hydrogen and this carbon. Okay, it's a radical. It will combine another normal molecule of chlorine which is available in the beaker. Okay, now it is the electron of this chlorine and electron of this chlorine. Okay, now this electron and this electron, they will combine together. So this electron will move toward this chlorine. So it will become H carbon with hydrogen. Okay, and now the chlorine will attach here, plus you will get this new chlorine radical. I hope you understand this point. Okay, so how chlorine is substituting one hydrogen from the alkane? So one by one. Okay, so the one by one, all these, for example, you have this hydrogen, this hydrogen, now you have one chlorine here, so you have another radical. Now This radical will substitute electron of this hydrogen. Okay, so this hydrogen electrons and this chlorine electron, they will combine together, and you will get this hydrogen carbon with this hydrogen. Now it will become radical because you can see this electron will remain with this carbon. Okay, and you will get Cl here plus this H and this Cl. It will combine together, you will get HCl. Okay, now it is another radical, so it will become H C with this hydrogen. It is a radical with this chlorine. So this radical will combine with the normal chlorine molecule from the beaker solution. So carbon's electron, chlorine electrons, it will combine with here, it will combine with here. So you will get H carbon, and it will become now another Cl substituted with the hydrogen, and plus now you will get this electron shift toward this chlorine, and you will get another radical. So one by one, until all these hydrogen, like this hydrogen, they will replace. Okay, in the next step you will get this Cl combined with this hydrogen, and you will get this Cl. It is a structure of chloroform, CHCl3. Yeah, it is CHCl3. It is actually chloroform. Okay, and the next step, what will happen? Very same procedure. You will repeat the same procedure. You will get this hydrogen will also replace with another chlorine. So you will get carbon tetrachloride. Carbon tetrachloride. Okay, you will get the final product. Okay, so it is the second step, actually propagation step. So what is the last step for this reaction? It is a termination step. Termination step. Okay, how this reaction terminate? Active reactive species react together. For example, during that reactions we got this radical, we also got this radical. Okay, when the radicals combine together, for example this and this, they will combine together, and you will get this CH3, then this, you will get this ethane. Okay, you will get this. For example, if you have this radical from the solution, any radical, okay, this radical combined with this Cl radical, they will combine together, and you will get this hydrogen with this hydrogen, and you will get this Cl. For example, we have chlorine radical plus we have chlorine radicals. Their radicals will combine together, and now you will get Cl2. Okay, so it is a termination step. You can see the highly reactive species, they are reacting together, and now you are getting less reactive species. Okay, so in organic chemistry, if electron pair is moving, so you will draw this double-headed arrow. It means this pair of electron is moving from this area to other. If single electron is moving, you will add this curly single head arrow. You can see it is a single head. It means one electron is being transferred. If there is a double head arrow, it means electron pair is being transferred. So in all these reactions, because only one electron is being transferred, it is the reason I am drawing this single arrow. Okay, I think it is enough for today, and in the next session, inshallah, we will discuss further about alkanes and their naming, especially how to name an alkane. Thank you very much. Allah Hafiz. Goodbye.